Welcome back. So today we are going to be looking at writing and balancing more complex half reactions that occur in specifically under acidic conditions. Now we can get them under basic conditions, but we won't be seeing that. We're only going to focus on acidic conditions. So what we are going to look at, or the compounds we're going to be dealing with, is going to be polyatomic ions and molecular compounds. So these undergo more complex half reactions than just metals and the nonmetals that we looked at last day from the single replacement reactions. So these here are going to take place under acidic conditions, therefore they're going to require specific techniques for balancing. So we don't really need to worry about the hydroxide ion, it's just mostly the hydrogen ion in present. So in order to balance these here under acidic conditions, first we're going to have to write the unbalanced half reactions to show the formulas of the given reactants and the products. So that's just kind of getting our half reactions, and we won't know which one's going to be oxidation and reduction, but once we actually get through all the balancing, then we'll figure out which one's which. So the first thing we're going to do is balance any atoms other than oxygen and hydrogen first. So that just means that we're just going to have a quick scan and just get, well, like I said, anything that isn't oxygen and hydrogen we're going to balance. Now next, in order to balance the oxygen atoms, so we're going to balance any oxygen atoms by adding water molecules to the opposite side of the equation. Once we do that, we're going to balance the hydrogens by adding the H plus ions to, once again, the opposite side to make sure that all the hydrogens balance out. And then finally, our last step is we balance the charges on each side of the equation by adding electrons, right? So right here, step 2 and 3 and 4 is balancing by mass, and step 5, of course, is balancing by charge. Now, we're going to look at steps for determining the net redox equations afterwards, where we kind of add them together, but first I want to take what just talked about right here and apply it to example A. So balance them following under acidic conditions. So that first step where it said writing out the unbalanced half reaction, so that means we are going to look at what is happening to, specifically here we can tell permanganate is going to manganese 2+, right? So this is an unknown half reaction, and same thing, we're going to have silver going to silver plus. So these are our two half reactions. So our first one, we got a blank because it's unknown half reaction. And why don't we get two colors so we can just tell. So the permanganate one is going to be in blue, and I will do the silver reaction in red, and this is going to same thing, an unknown half reaction. So for our permanganate example, we are starting with MnO4 minus, something's happening to it, and it turns into Mn2 plus. So our first step is write out, of course, our half reaction, write the unbalanced half reactions. In this case right here, I'm just going to deal with the permanganate one first. So this is our unbalanced half reaction. We got MnO4 minus going to Mn2 plus. So our first thing that we do after we write out our unbalanced half reaction is this step right here. So balance any atoms other than oxygen and hydrogen first. So that means we're going to have to look at the permanganates. So our example right here, we can tell that we have one permanganate and one permanganate. So step number 2, we're all balanced. Now step 3, where it said balance any oxygen atoms by adding water molecules to the opposite side. So we're going to scroll down here again. We can see that on our reactant side we have 4 oxygen molecules, and our product side there's 0. So in order to balance that out or get enough oxygens, I need to add 4 water molecules to the opposite side. So now I have 4 oxygens and 4 oxygens. Now by adding that water, so that's step 3, then we move on to step 4, balance any hydrogen atoms by adding the H plus ion, the hydrogen ion. So now when we are scanning, same thing over here, so on our product side we have a grand total of 8 hydrogens because it's H2O and there's 4 of them, so we're going to have to balance or add 8 hydrogen ions to the opposite side to balance out our hydrogen atoms. So our permanganates are balanced, our oxygens are balanced, and our hydrogens are balanced. So right now we have everything balanced by mass, and that's when we go to our last step to balancing under acidic conditions, is balance the charges on both sides. So when we're balancing the charge, I'm just going to write this down underneath and then erase afterwards. We have to look at, how much the charge on each atom, and then of course how many atoms there are in total, or how many compounds. So we got MnO4 minus, so we have one of those, and it has a -1 charge. Now we have 8 hydrogens that has a +1 charge, right? So the total charge on my reactant side right now is a +7 charge. On my product side, I have Mn2 plus, and I got 4 H2O. Now water does not have a charge, but my permanganate does. So I have just one of those, so I have a +2 charge on my product side. Now of course I can only add electrons, so in order to bring my reactant side down to match the charges right here, I need to add 5 electrons, right? Because +7 plus a -5 will give me a +2, and that's how both of those sides can equal out. Now, just kind of filling in what we just created here, we have our 5 electrons on our reactant side, so this is obviously my reduction half reaction, which hopefully my silver is going to be my oxidation half reaction. And just to kind of make sure, we're going to go through the exact same steps where we write out our unbalanced half reaction first, like this, and then we go through our steps. So we balance mass first, so everything that isn't oxygen and hydrogen, so that's just silvers, are balanced. When we go through our steps of balancing oxygen and hydrogen, well, there's no oxygen or hydrogen there that we need to balance, so we only need to do our last step and balance by charge. And in order to do that, we have a 0 charge on my reactant side, we have a +1 charge on my product side, so I need to add 1 electron to balance them out. All right, and then of course, last step is, of course, getting the redox, so adding them together. So steps for determining the redox reactions are right here. So first step is, of course, find the lowest common multiple needed to balance the number of electrons. So from our reduction half reaction, we have 5 electrons. From my oxidation half reaction, we have 1 electron. So lowest common multiple, I have to multiply my bottom equation by 5. So in order to do that, now we're going to get new coefficients. Going to look like this, and we add them together. Now we do have to be careful, cancel out electrons in any other identical molecules, so very similar to Hess's law, that's if they show up on opposite sides. If they show up on the same side, we're going to add them together. So what we have right here, now we have 5 electrons on our product side, they're going to cancel out with our 5 electrons on our reactant side, and that should be our only thing that gets canceled out. So we write our redox of MnO4 minus plus 8H plus 5Ag. Now I am leaving out states of matter here just for room, but we know all ions need to be aqueous. And of course, if it's an element, it's going to be solid. And that is what our redox equation will look like. Now step 4, if spectator ions were removed when we're forming our half reactions, we add them back together. So that kind of goes back with the last lesson there when we dissociate all of our highly soluble things, so look for spectator ions to kind of take them out. So if there are spectator ions there, we can put them right back into our net reaction if we want to. And that's balancing our half reactions. So if you think you might have a hold on this one right here, please pause the video and just try B and C, and then of course the old diploma question right here. But if you do want a little bit extra help, I'm going to go through the exact same steps with B here now. So same thing as the previous example. We're going to look at what things are changing. So we can tell I2 is going to IO3. So that's going to be one half reaction. And the other half reaction is OCl minus going to Cl minus. So we can write those in. Now, same thing, I don't know what's going to be oxidation or reduction, so I can just kind of leave it blank, right? Our unknown half reaction, the blue one, so we're going to get I2, leave myself a lot of space, going to IO3 minus. And same thing, my other unknown half reaction, I got OCl minus going to Cl minus. And once again, I'm leaving space here just because I know I'm going to have to add electrons and stuff like that. So for my first balancing of this half reaction, once we write out our unbalanced half reaction like this, we balance everything that isn't oxygen and hydrogen first. So that means we balance our iodines. So on our reactant side, we have 2 iodines. On our product side, we only have 1. So I need to make sure that I balance that, stick a 2 in front. Now next, I need to balance my oxygen atoms by adding water. So on my reactant side, I had 0 oxygens. On my product side, however, I have 6 oxygens right now because we got 2 IO3s. So I need to add 6 water molecules on my reactant side in order to balance out the oxygens. Now, after we add our water molecules, we balance our hydrogens by adding H+. So on my reactant side now, I have 12 hydrogens. And on my product side, I have 0, so I need to add 12 H+. In this side of the equation to balance out the hydrogens. And finally, we balance charge. So on my reactant side here, iodine has a 0 charge, water has a 0 charge, so we have 0 charge on my reactant side. And on my product side, I have 2 negative coming from IO3, and I have 12 positives coming from my hydrogen, so I have a positive 10. So in order to balance out this, I need to add 10 electrons on this side to bring me down to a neutral 0 charge. Alright, so the second one, we're going to do the same steps. So we balance everything that isn't oxygen and hydrogen first. That's our chlorines. So we have 1 chlorine molecule, 1 chlorine molecule here, or 1 chlorine atom, 1 chlorine atom, so we're good with chlorines. Next, we need to balance our oxygens by adding water. So we have 1 oxygen on my reactant side. So I need to get 1 water molecule on my product side to balance out the oxygens. Next, I balance out the hydrogens by adding H+. So I have 0 hydrogens on my reactant side, but I have 2 on my product side. So I'm going to have to add 2 hydrogen ions on my reactant side to balance those out. And finally, we need to balance charge. So on my reactant side, I can tell I have a positive 1 charge, right? Because I have 1 negative charge from OCl minus, and I have 2 positive charges from my hydrogens, and I have a negative 1 charge over on this side. So in order to balance out the charges, I need to add 2 electrons on this side right here to bring it down to a negative 1 charge. So of course, naming our half reaction as well, so electrons and a reactant. So this is my reduction half reaction, and the top one, I forgot to put that in earlier, this is my oxidation half reaction. Alright, now as for the net, or my redox, I'm going to add 2 of them together. But before I do that, I need to make sure the electrons balance out. So I got 2 electrons in my reduction half reaction, 10 electrons in my oxidation half reaction. So its lowest common multiple between 10 and 2, of course, is going to be 10. So I'm going to have to multiply my bottom equation, once again, by 5. So I'm going to get new coefficients in front of everything. So these are the new coefficients. All right, so now we are going to see more things canceling out than just the electrons. So we know that we have 10 electrons in my oxidation half reaction, 10 electrons in my reduction. So the total number of electrons are going to cancel out. Now, as for the other things, we will notice that from my oxidation half reaction, I have 6 waters, and in my reduction half reaction, I have 5. Now, what's going to happen is the waters are going to cancel out, but they're obviously not going to completely cancel out because I have more waters on the reactant side. So basically all of these waters here are going to cancel out, and then all of them but one is going to cancel out here, right? So we're just going to be left with 1 H2O on this side right here, because 6 minus 5 gives us 1. Now, same thing with the hydrogens. We have 10 hydrogens as a reactant over here, but 12 as a product. So we have an excess amount over here on the product side. So all 10 of these are going to cancel out, and we're going to be left with 2 H plus on this side. So what we're left with in our redox, we got I2 plus 5OCl minus plus our 1 H2O. It's going to produce 2 IO3 minus plus 5Cl minus, and then our excess of 2 H plus. And that is our balanced redox reaction for this one right here. All right, now for the last one, saying I'm going to put the answer now in a second, but please, if you want to, just kind of pause the video and see if you get this answer. So the answer is going to go up in 3 seconds. And you should get something that looks like this for C. And last but not least, the old diploma example that we have right here. So we have an incomplete unbalanced half reaction right here, so Br2 going to BrO3, and this one right here just says which of the following rows identifies the lowest whole number coefficients for water and H plus that is required. All right, so the answer you should get for this one is D, and the reason for that is when you do balance this one out, right, we balance everything other than oxygen and hydrogen first, so we need to have a 2 in front of there. That'll give us 6 H2O on our reactant side and 12 H plus on our product side. Now, it doesn't say anything about the electrons, but if we did want to balance out the electrons, we can stick 10 electrons over here as well, and that of course means that we have an oxidation half reaction. And that is it. So inside your workbooks there should be a lot of examples for this one right here, so please work through, and of course if you have any questions we can bring them out when we do our extra help session later. Alright, see you guys later.